We are also recording today's webinar, so if you miss any section due to technical issues or you want to share, we should have a copy of the recording available on the National Hurricane Center's YouTube page, which should be provided in the chat box on your GoToWebinar control panel. So my time shows 1300 Eastern time, so we're going to get started with a welcome and some opening remarks. Once again, welcome to the 2021 NOAA Marine Forecasting Workshop. I'm LTJG Lexee Andonian, and I will be today's moderator. I share the operations manager role with Lieutenant Phil Manougian for the Storm Surge Unit at the National Hurricane Center down here in Miami, Florida. We provide the fleet storm surge decision support during the hurricane season and act as the we act as the National Hurricane Center liaison for the NOAA fleet. Before we get started, I would like to take a moment to thank Captain Simon, Captain Shoup, Captain Zegowitz, the rest of the MO branch, and Dr. Chris Landsea for coordinating today's workshop to support the NOAA fleet. So let's get started. We have a lot to cover in a short amount of time. Thank you again, everyone, for joining. The NOAA Marine Forecasting Workshop has been organized to aid in the understanding of the forecasting process and products from the Ocean Prediction Center and the National Hurricane Center. Topics will cover marine forecasting in the North and South Atlantic, including the Caribbean, Gulf of Mexico, and hurricane analysis and forecasting, along with storm surge products and uses. Today's webinar is designed not just for COs making important go, no-go action plans, but to facilitate all vessel operators accessibility and understanding of marine forecasting products and to aid in safe vessel navigation. We have 4 presentations for you today covering the aforementioned topics. At the end of each presentation, we've saved about 5 to 10 minutes for questions. If you have questions, please write them in the question box of your GoToWebinar control panel, and I will address them in the order they are received at the end of each presentation. So let's get started with our first presentation. It's my pleasure to introduce hurricane specialists Andy Latto and Brad Reinhart at the National Hurricane Center. Andy and Brad will spend about 45 minutes on their presentations pertaining to hurricane analysis and forecasting, with about 10 minutes for questions at the end. Thank you, Andy and Brad. The floor is yours.
All right, thank you, Lexee, and good afternoon, everyone. My name is Brad Reinhart. I'm a hurricane specialist here at the National Hurricane Center in Miami. Stand by for one moment, and I will share my screen here. All right, and can I just get a confirmation that people can see my screen?
Brad, this is Lexee, and I've got your screen.
Excellent. All right. So today, Andy and myself will be talking about the hurricane analysis and forecast process, as well as some of the forecast products that can aid in your decision making when practicing good avoidance for tropical cyclones. So I'll just start with a brief, introduction on some climatology. And if we look at this map here, which shows the tracks of all tropical cyclones, known tropical cyclones in the Atlantic, dating back to the mid-1850s, and you can see that they've impacted just about everywhere in the Atlantic Basin. There's really nowhere that hasn't at some point seen, tropical cyclone activity. And as mariners, obviously, this chart really speaks to the importance of knowing where these systems are located, where they're going, and how you can, avoid their impacts. Now, this graphic breaks out major hurricanes, and so those would be hurricanes with wind speeds of 96 knots or greater, category 3 or higher on the Saffir-Simpson hurricane scale. And some notes on these: the vast majority of these systems occur during the months of August, September, and October, when you generally have the warmest sea surface temperatures and the weakest vertical wind shear, which are both, which would combine to produce most favorable conditions for strengthening of these systems. And you can also see that most of these many of these are long track systems that generally form from African easterly waves out in the East Atlantic, and can have far-reaching impacts across the Caribbean, and then depending on the steering currents, can impact the United States East Coast, the Gulf of Mexico, Caribbean, etc. So if we look at just a climatology of when do tropical storms and hurricanes occur in the Atlantic Basin, this chart, you can see here at the top, it's got some dates with some vertical lines, as kind of a time reference as we go through the hurricane season. So brief refresher, Atlantic hurricane season runs from June 1st to November 30th. You can see from this chart that the peak activity really occurs from mid-August to late October is when you tend to see the highest number of storm counts in the Atlantic Basin. But one interesting thing about this chart that I'll call your attention to is the fact that, we talked about the season running from June 1st to November 30th, but you can see that it is, not impossible for storms to occur before or after the season. Fortunately, we haven't had any after the season this year, but for the past several years now, we've actually had storms form before the official start of Atlantic hurricane season on June 1st. So while these are statistically maybe the most, the hurricane season defines the most favorable time, certainly, it's important to, keep good situational awareness year round and pay attention for those, systems that may occur outside of the hurricane season. So if we now take just a brief look at, some of the favorable formation areas by month in the Atlantic. And so we'll start off in June, where most of these storms are generally going to form in either the Northwest Caribbean Sea or the Gulf of Mexico, where the water temperatures are warmest, in the early summer months. You can see that by July, your development areas start to spread east and cover more of the West Atlantic and the Caribbean Sea, in addition to the Gulf of Mexico still. By August, now you can see these warmer colors indicating that, tropical cyclones are more likely to form. And this is where you really start to see, as we talked about, that kind of peak with, ramping up the number of tropical cyclones in any given year. Additionally, these are when major hurricanes, become more likely. We talk here with this last bullet point about the Cape Verde season, usually beginning in August. And that's just simply these longer track tropical cyclones that have plenty of time to move across warm waters and have the potential to intensify, become stronger, and become more damaging systems wherever they may eventually impact. September, as we talked about, is kind of that climatological peak of the season. And really at this point, atmospheric and oceanic conditions are usually favorable for storms to form nearly anywhere in the basin. And so, this is again where we're looking for some of those longer track storms, but you can see just from the colors here that really anywhere in the West Atlantic, Gulf of Mexico, Caribbean could be fair game. Then we start to see, sort of secondary peak of the season as we get into, the early and mid part of October. This is usually when the Cape Verde season ends, so we're not seeing the longer track systems, but the development area shifts back to more of the Western Atlantic and the Caribbean, Gulf of Mexico. And then by November, the frequency, you're much less likely to see storms, although, in a given year like this, where we had anomalously warm waters there in the Northwest Caribbean, and we had 2 major hurricanes down there. So certainly these are just climatologies. These are, averages, what you might expect in a given year, but certainly, conditions can change. And in any given year, you may see more or less systems, just to give you a kind of a brief background. So now we'll transition to talking about some of the products that can keep you informed about hurricanes, tropical storm formation before they form. And so I'll start with one of our well-known products known as the Tropical Weather Outlook. And so you'll see here on the left, this is an example of our graphical tropical weather outlook. And this particular one is the 2-day graphical tropical weather outlook. And so this chart, or this map, gives you both the location of active tropical cyclones. So in this case, the red symbol here indicates that there is an active tropical storm in the vicinity of Bermuda. But then also you'll see some X's that have different colors and percentages associated with them. These are formation areas that we're monitoring for possible development, and the probabilities, the numbers you see in parentheses, are simply categorical probabilities that convey the chance of formation during the next 48 hours. And so low would be yellow, orange would be medium, red would be high. So in this particular case, there's a couple of systems we're monitoring. There's one with about a 50% formation chance during the next 48 hours. It's approaching some of the Lesser Antilles. And you can see there's another system further out in the central to eastern part of the tropical Atlantic basin of the low probability during the next 48 hours. I don't think we have it on this slide, but there's actually an accompanying text product with this. And so when you view this product on our website, if you hover over these formation areas, it'll show the accompanying text. That'll normally just give a brief description, kind of characterize the system we're monitoring, whether it's just a tropical wave, some type of broad low pressure system, and gives a general idea of where it might move over the next several days and what kind of conditions might be favorable or unfavorable for its development. So this is a similar product, except this is the 5-day graphical tropical weather outlook. And so similar conventions with the color-coded shading of formation areas. The only difference is this one's giving the chance of formation during the next 5 days. You can see here that the X's mark the initial location of the disturbance. And then the hatched area or the shaded area represents the potential formation area, which is a little bit of a misconception. It doesn't represent necessarily the future track of the system. It just gives the area where genesis or formation of a tropical cyclone might be expected. So something to keep in mind when you're viewing this product online. All right, so that covers kind of before we get formation of a system. And so now once a storm forms, as hurricane specialists, it's our job now to provide forecast information for the protection of life and property. And so before we can do that, when we go through the forecast process, there's some questions that we have to answer as forecasters. First of which being, where's the storm located? Latitude, longitude, what's the position of the center of the system that we're monitoring? Which, seems elementary, but that can actually often be challenging, especially for systems that are in the early stages of formation, maybe weaker and lack a well-defined center. Obviously, in a case like this, with the picture we have here to the right, a hurricane with a nice, well-defined eye, it's pretty simple. But sometimes even just determining where that storm is initially located can be a challenge. We also want to answer the question, how strong is the storm? As we in all of our products, we give a wind speed that represents the maximum sustained winds anywhere within the circulation of the storm. And then third, we want to characterize how big is the storm. And so we do that through by providing tropical storm and hurricane force wind radii, which can also be challenging. And the last bullet point there talks about some of the data sets that we use to characterize and get an idea for the size of the storms. Things like ship observations, buoy observations, very helpful. Aircraft reconnaissance data, when available, is very, very helpful to us as well. Scatterometer data, which scatterometer, simplest way to think of it is basically just a radar that's mounted on a satellite up in space, and through the information it gives us, we can kind of derive wind speeds and directions over the open ocean where we may not have other available data. And so that can also is a very valuable tool for us in terms of determining, okay, what are the kind of wind speeds are we seeing in a storm, where is it centered, things like that. Very helpful data sets, but they're not always available. And I don't have to tell mariners that, the ocean's a very vast region, and we have somewhat sparse data coverage over these areas that we're trying to forecast for. So certainly these questions are crucial to make good forecasts for tropical storms and hurricanes, but can also be challenging. And we'll talk about that now, some of the analysis uncertainty. So you can see we'll start with location uncertainty, and for tropical storms, it's usually 25 to 45 nautical miles in terms of where we say the center is versus where it may actually be. That's kind of a buffer to think of uncertainty that we may have when trying to pinpoint where these storms are. You can see that the location accuracy improves as the storm gets stronger. For hurricanes and major hurricanes, obviously the uncertainty error is much lower. Simply a product of the fact that oftentimes these kind of systems have eyes and more well-defined circulations that are easier for us to track and identify, even via satellite data. For our intensity analysis, it's believed to be good within about 10%. And so when we issue an advisory that says a hurricane has maximum sustained winds of, say, 100 miles per hour, the reality is it could be closer to 90, it could be 110 miles per hour. This chart here on the bottom right kind of gives an example. You see a lot of data points there. I won't go into much detail other than to say that these are all data sets that we're getting in real time when we're trying to come up with an intensity estimate for a hurricane. Some of these are objective satellite techniques for determining the intensity. Some are subjective analysis, satellite analyses that are provided from another branch in the Hurricane Center that we'll hear from later. Some of these might be reconnaissance data, either flight level winds from the hurricane hunters, or drop-zone data, which is instrumentation packages that are released from the aircraft and can provide us more information about the wind speeds in the lower parts of the atmosphere in a storm. So the key point is to take away from this graphic is if you go down at any particular time step, any one of these vertical lines, you often see a large spread in the information that we're receiving in real time. And so that's why when we're doing our best to come up with an initial intensity, there is still kind of a 10% uncertainty, just based on the availability and the limitations of some of the data sets we use. And then the wind radii that I talked about. So the tropical storm force wind radii, I believe to be good within about 25%, and the hurricane force wind radii about 40%. We'll talk a little bit more about that on this slide. So what do we mean by the wind radii? Well, that's simply the largest distance from the center that winds of a certain threshold are occurring in a particular quadrant. So you can see here for this particular example, down here in the bottom left in this black box here, it gives some quadrants for 64 knots or hurricane force winds, for 50 knot winds, and then for 34 knot winds, which would be tropical storm force. And the way we characterize these, because again, it is the largest distance from the center, kind of leads to a natural overestimation of the wind extent in some cases. So it's important to keep in mind when you're using this information that when we say, tropical storm force winds are occurring within 175 nautical miles in the northeast quadrant of this storm, it doesn't necessarily mean that everywhere within that 175-mile extent, tropical storm force winds are occurring. In fact, most often that's not going to be the case. But these radii just represent the largest distance from the center that those winds are occurring in a particular quadrant. And so some of the tools we can use for that, we've got a variety of model guidance, some climatology and persistence models as well. And some of the ideas when we're thinking about that, just simply, okay, is the storm strengthening or weakening? When storms transition and become extratropical, the wind field tends to expand. Is part of the circulation passing over land and land interaction that would obviously decrease maybe some of those wind speeds due to frictional effects. What about the system's motion? Is it accelerating so that the storm's wind field may become more asymmetric? These are all some empirical ideas that we keep in mind as we're trying to make these forecasts for wind radii on top of the guidance that is available to us. So now we'll move on to the tropical cyclone track and intensity forecasting. Talk a little bit about this. Track forecasting is a relatively simple problem. We often use the cork in a stream analogy. Basically, the storm is embedded within an environment that where the large-scale atmospheric features that would control the motion of the storm usually are large-scale and easy to measure. They're usually well represented in the guidance, and so you can think, using the analogy of a cork in a stream, throw a cork in a river or something, and it's going to move with the general flow within the body of water. Same with tropical storms or hurricanes. Just think of it as instead of the atmosphere is a fluid, and so these features, wind patterns and whatnot that control the motion of storms, are usually well represented by our global model guidance. Now, intensity forecasting is a much more complex challenge. First of all, it's oftentimes dependent on the track. So if you get the track forecast wrong, your intensity forecast is also likely going to have errors. Additionally, intensity involves more smaller scale interactions within the storm, between thunderstorms in the core of the cyclone, the environment, some oceanic factors. There's internal processes such as eye wall replacement cycles that we're still trying to understand and forecast better and anticipate. But intensity not only dependent on the track, but also smaller scale environmental conditions within the core of the cyclone, in addition to some of these internal processes that are challenging. So when we look at our forecast track errors and we say, okay, well, how are we doing in terms of forecasting the track of tropical cyclones? And from this graph, you can see that we're definitely getting better. And you can see really starting since the 1990s, these errors, these track errors, which are represented here on the vertical axes, are decreasing over time pretty substantially. In fact, the current errors from our past decade, 2010 to 2019, have actually reduced by about 2/3 since the 1970s and about 1/2 since the 1990s. It really is a credit to the improvements in numerical weather modeling that often serve as guidance for our track forecasts. As the models have gotten better, we've learned how to use that information to make better track forecasts. Just as an example, in 1990, if our 3-day forecast called for landfall in the vicinity of Biloxi, Mississippi, say, with this gold square here, the average forecast error in 1990 would encompass much of the northern Gulf Coast from Galveston, Texas, all the way to the Florida Big Bend. And so that was the uncertainty, or the average error for a 3-day forecast in 1990. Whereas for today, you can see with that red circle how much of a difference, how much of an improvement we've made in track forecasting. Now, if we were explicitly calling for a day 3, landfall, showing landfall in the Gulfport Biloxi area, now it might just, the error might encompass portions of southeastern Louisiana, Mississippi, and southern Alabama. So our forecast errors are significantly lower, which allows us to pinpoint the areas that are most likely to be impacted with much higher confidence. And as we said, the advances in model guidance, in the technology of numerical weather modeling are primarily responsible for a lot of these improvements in the track forecast. And so here's a chart that just shows our track forecast error over the past 5 years by day. So down here on the forecast periods here on the bottom, 24 hours, 48, 72, 96, 120. In general, track errors increase by about 30 to 40 nautical miles per day. Just something important to keep in mind when you're making forecasts based on, or making decisions, based on, day 3, 4, and 5 forecasts. Keep in mind that as we go out further in time, there's going to be inherently more uncertainty in the forecast that we're making. So now we'll get into the tools that we use to make the track forecast. And I think this is important to cover. I'll kind of go through it quickly, but this plot here on the left, the spaghetti plots as they're commonly known as, people commonly share and view these online. And I'm sure all of you on the call have seen these at some point in time, whether it's on social media, on the news, etc. It's important to note that without a deeper understanding of the strengths and limitations of each one of these models that's depicted with a colored line, you can really make bad decisions by misinterpreting the data. And so that's why we always stress the importance of using the official National Hurricane Center forecast, when making decisions. So when we think about what do these lines represent, do they convey the uncertainty in the track forecast? Are they all created equal? Well, let's look into that a little bit more. So some of the different types of guidance that are included in these spaghetti models. So you have extrapolated motion, which is just simply used if the models aren't handling the initial motion of the storm very well. It doesn't really have any utility beyond about 6 or 12 hours. So this really isn't a forecast tool that we're using very often. There's also climatology and persistence models, which are simply used as a baseline to compare other forecasts with. These aren't used as a forecast tool either. So if you just looked at that line on a spaghetti plot and tried to draw a conclusion from it, you would be doing yourself a disservice, because this isn't something we're actually using as a forecast tool. Some of the global weather models, some of the names or acronyms you might be familiar with, like the GFS, the European model, ECMWF, the UK Met. These are models that are very good for tropical cyclone track forecasting. As we kind of talked about earlier, they handle the large-scale pattern and the steering flow very well, and thus, give us good information when we're trying to forecast the track of a tropical cyclone. However, these global models don't have the resolution to really see the details of the inner core of a tropical cyclone, and so they can struggle with the structure and thus the intensity forecasts, which ultimately can have an effect on the track as well. There's also regional hurricane models that are developed specifically for tropical storms and hurricanes. They have a higher resolution, which means they can potentially do better with intensity forecasting, interactions between the tropical cyclone and its smaller scale environment. However, the limited coverage means that they may not handle the large scale steering flow as well. And so longer range forecasts can be degraded because of that reason. And then there's what we call consensus models. And these are typically the best track guidance that we have. These are sometimes just simple or weighted averages of the most reliable guidance available to us. And they can be very useful if all the members of that consensus are showing a similar forecast scenario. But if they're very different, if they're divergent, then it's not going to work very well. So these are all things that as hurricane specialists, we're, the knowledge that we've accumulated and things that we're keeping in mind as we're interpreting this guidance and making the best forecast possible. It's not really something that we would expect, an average person to be able to get. So just a fair warning when you see those spaghetti plots to keep in mind, there's a lot more to it. And, your best bet is going to be to trust the official forecast that we're putting out there. And so now I'll turn it over to my coworker, Andy Latto, who will discuss more about the NHD Intensity Forecast and then some of the forecast products that you can use to make decisions for tropical cyclones. Bear with me.
Hey, Brad, thanks. Everybody, this is Andy Latto. I'm also a hurricane specialist at the National Hurricane Center. I'm going to start off by talking about, so how have our forecasting at the Hurricane Center, how has that improved over the course of the last decades, actually? So going back in time, these lines kind of represent decades of track forecast errors that we've had. Sorry, this is intensity forecast. So back in the 70s, the blue line here, you can see the errors were a bit higher than they currently are the past decade, 2010 to 2019. You also notice here the lines don't extend past 72 hours until the year 2000, because we weren't issuing forecasts for intensity beyond that time up until the previous 20 years. But the overall, you can see, especially in the medium to long range forecast time periods, that we've been getting better at intensity forecasting. We still have, you see, about 15 knots worth of error, dating about 3 days and beyond, which is at least one category, if not more, of difference in storm. So there is a lot still of improvement that is potentially there, but we have been trending the right direction. And so you notice that in the last 5 years, the forecast intensity has narrowed just a bit more. It was just over 15 for that 10-year period, but now it's down to 14. You also notice, though, the forecast skill levels off kind of after day 3. So our intensity errors are about the same, roughly the same, day 3 and beyond, but they get a lot better as you get closer to the current time frame. So I'm going to go over the different products that we issue for forecasting tropical cyclones. Once we issue an advisory, these are all the things that are available at your disposal to take a look at to try to make your decisions to try to get avoidance of these systems and their hazards. One of the most popular ones is the products that convey uncertainty is our cone graphic. And we speak of uncertainty because we try to convey the possibility of errors in the track and intensity in our forecast and how to build that into your thought processes when you're trying to avoid these hazards. So basically, the cone graphics is the probable track center of the tropical cyclone, which you see in the dots that have the letter M, that's major hurricane. But the cone is formed by connecting circles centered on each of those forecast points. And it's basically a 67% chance that the storm will be inside that circle in that certain time. And I say 67%, so 2/3 of the time it will remain in that cone, but 1/3 of the time the center of the storm will go outside of that cone. And so you have to anticipate possible impacts not only well away from the center, but you also have to anticipate that the center could very well be out at the side of that cone at that specific time frame. And so the cone only displays information about track uncertainty. We don't illustrate anything about specific impacts, whether it be surge, rainfall, tornadoes, for example. We have other products that do outline that. I'll get to that here in a minute. and also doesn't say anything about storm size. It could be a very giant storm. You see this particular example, this orange shaded region in southern Florida is the extent of Hurricane Irma's tropical storm force winds. Very large storm, way outside the cone. So those impacts were extending far outside, either left or right of that cone. And so knowing the size of the storm can help you build in some uncertainty outside the cone about where you should avoid these conditions. Again, 1/3 of the time, the storm will move outside of that cone area. Okay, so going into some of our text products, these products will help you see some of the other information that's kind of behind the scenes. So a good example, this is one from Hurricane Joaquin, a TCD, we call it the forecast discussion. At first, we will usually have some forecast reasoning. So we'll say, this is what information we have to tell you how strong it is, whether it be a Hurricane Hunter aircraft or satellite intensity estimates, for example, the reasoning behind its strength, and then relevant observations that pertain to it. We'll talk a little bit about model guidance as far as track's concerned, and then we'll also have another paragraph typically about guidance and the reasoning behind what the intensity is going to be. And we'll also discuss any forecast uncertainties that might occur. So in this example, we think Joaquin's intensify a bit more in the next 12 to 24 hours because it's going to be over warm waters, decreasing shear. But then later on, fluctuations could occur due to eyewall replacement cycles. Another example would be we talk about increasing shear, which could weaken the storm, and so on. And then we go about talking about the track. We say if there's a strong ridge in place, it's going to keep driving a storm westward. We'll discuss that in there. If the models are all over the place, lots of uncertainty, a lot of track error, we're going to talk about it in there and say this is a low confidence forecast. And so when you're trying to plan your routes, you're trying to make your decisions based on what's going out there, you can kind of get an idea, like, build in your room for error for any of the specific situations dependent on the storm and that situation at the time. We also have, especially when there's a storm that's expected to have major impacts, we have key messages. It's not in every single advisory we issue, but typically if we think it's going to be affecting land areas, we'll add these in there. And so we highlight the specific threats in here and also the forecast confidence. So we'll say whether or not it's going to be a major surge threat or rainfall threat, or it's going to be a major wind threat, or all of the above. That information will be inside these key messages, which is also tagged at the bottom of the tropical cyclone discussion, but it's also embedded on our webpage, and I'll show you that graphic here in a minute. Also in the tropical cyclone discussion is the table of the track and intensity forecast, and this is available in a lot of different other products we issue. So the wind speed probabilities, this is actually the text version of it. We have the graphical version of it as well, and we show a list of location-specific probabilities. These are calculated through a variety of models that run. And so we list tropical storm force winds, 58 miles per hour, which is 50 knots, and hurricane force winds. And we'll list the probabilities for each of those locations. So for example, Pensacola, the number 34 is in the second column, 50, and then 64 is in that same column. Those are the wind speeds. And to the right are the cumulative probabilities in parentheses and the single timestamps in that particular time frame. There's a better example here I'm going to show you here in a second for that. And then what falls out of it is a graphical product showing the cumulative probabilities for the zoomed out area over the region. And that's what this is here. So basically you're seeing the graphical format of that text product. So all those probabilities are plugged in and made into this nice pretty product that shows the higher probabilities in the warmer colors, and then the lower values, the yellows and greens. And those are all, again, available on the web page after the advisory comes out for each time frame every 6 hours. And this is for 34 knot winds, 50 knot winds, and 64 knot winds. So this is an example for 34 knot wind probabilities, 50 knot wind probabilities, and hurricane force wind probabilities. So how do we create these? So we run a model that actually shows 1,000 different possible scenarios that the storm could take, a track that could take. We use historical NHD track and intensity errors, and we run it with a climatology and persistent wind radii model to generate these 1,000 alternate scenarios. And so you take a specific location, let's say, it also takes into account weakening over land, so you have lower probabilities as the system moves inland. That's a recent addition. And the past track forecast errors are also built in to that guidance. So let's say you live in New York City and your location of interest is there, and we run those 1,000 models. And the model comes up with 590 of these produce tropical storm winds during the scenario at that location. Well, your probabilities are then going to be 59% chance of tropical storm force winds. And it does the same for 50 knots and 64 knots. But going back to that text product for the wind speed probabilities, so how to interpret this. So you have each timestamp, the forecast hour towards the top here, 12, 24, 36, 48, and so on. So at Pensacola, the 34 knot winds have no chance at 24 hours, but 10 at 36, 32 at 48, and the cumulative is in the parentheses, so it's just basically adding 10 and 32. And then so on for the rest of the time frame. So the best chance of tropical storm force winds reaching the area are probably the 48, 72 hour time frame. The reason I'm showing you this, not only because you can refer to this for specific locations, but also we have another product, the time of arrival, that is derived from this information. And so it uses the timing information from those wind speed probabilities to build two different products, the earliest reasonable time of arrival, which you're looking at here, and there's also most likely. You're going to see both examples. And it accounts for the typical track intensity and size forecast and uncertainty of a tropical cyclone, of that tropical cyclone. Here's an example of the earliest reasonable time of arrival. And so what you'll typically see, especially with verification, is that most of the time the winds will not arrive that quickly. The reason with this product is created, and you can see the arrival times are basically 12-hour increments. If those that you want to make sure you don't have those winds, you have your preparations in place before that time. So if you have a low tolerance for tropical storm force winds, you'll want to make sure all your preparations are complete before this time arrives. So for example, if you lived along the northern Gulf Coast, you want to make sure your preparations are complete a little bit before 8 o'clock on that Saturday evening. The most likely arrival is exactly what it says, most likely time that these winds are going to arrive. And so I'm going to go back, 8 p.m. was the earliest, if you live just inland Pensacola, 8 p.m. was the earliest reasonable, 8 a.m. is the most likely. And so if you're a little bit higher threshold for your preparations and you want to just make sure your stuff is done before the winds will likely arrive, then that's going to be the time frame you're going to be looking at. And what I also then mentioned is that behind this, the shaded is those actual probabilities and those colors that we were looking at in the other products earlier. All right, so I mentioned the key messages are going into different products. So when you go to our homepage and there's a storm out there, you'll see, let's say for Hurricane Irma, you'll see a list of all the products that are available. A bunch of different tabs are available for graphics, for text products, key messages. If it's a storm that's probably threatening land, key messages should be there. And if that's the case, then you'll have that available to look at. It's kind of a good one-stop shop to kind of highlight what all the threats are going to be, what some of the timing information is going to be. As you can see on the right-hand side, we have a couple select graphics we can pick at our choosing to put in there. In this particular case, we put the the cone graphic, the watches and warnings are highlighted on that product as well. And also as well on that same product are the wind radii. You can see in the orange shaded color with a current center over the northern Leeward Islands. And then the tropical storm force wind speed probabilities is on there as well. There's other different products we can put into that in the graphics, and typically just do it pertaining to the biggest threat at that moment in time. So you might sometimes see rainfall graphics in there if it's going to be a big rainfall threat, and there's other tools available in there as well. Now I'm going to talk about the hurricane watches and warnings. This is pertaining to the coastal watches and warnings. TAFB, of course, has different ones, and they'll discuss those here in a little bit. Hurricane conditions are possible with the hurricane watch generally within 48 hours. And the warning is expected, so a higher likelihood within 36 hours. Now, you have to remember the lead time for the watches and warnings is actually tied to the anticipated arrival time of tropical storm force winds, not hurricane force winds. And so when you see these products issued, we're anticipating that, yes, the hurricane conditions are expected within 36 hours, but we're expecting tropical storm force winds to arrive by then. So how big is the warning area? Do we play it safe and just make a warning for the entire northern Gulf Coast when there's a storm approaching it? No, it's because we have to make sure it's more concise. It's higher confidence warning to make sure people act and people take it seriously. The warning size is based on the forecast track, the storm size, and the known uncertainties in that particular storm. This particular example shows that the warning area is, you take the main track, the current forecast track, and they added the 36-hour forecast average area on either side for the hurricane warning area. Well, that's good for a general rule of thumb. Well, what happens in different scenarios? Let's say the models are all over the place. It's a very low confidence. You might want to expand that warning area a little bit to build in a little bit more uncertainty. What if the storm is very large? Let's say the hurricane force wind extends out 20 miles on the left side, 100 miles on the right side. Well, instead of having the hurricane warning area covered all the way to the left and right equal distance, you might have a smaller area to the left and a larger area to the right of where your anticipated landfall location is, especially when you have a high confidence forecast. Also, the orientation of the forecast track with respect to the coast. So in this particular example, you're seeing the pretty direct hit. It's heading straight towards the South Carolina coast in the forecast. Well, think back on last year, Hurricane Isaias. We had tropical storm warnings or hurricane warnings at one point in time, or over the course of a few days, covering Florida, South Carolina, North Carolina, Virginia, all the way up through portions of New England. It's because the storm was moving near parallel to the coast, and some of the tropical storm force winds were expected to remain offshore. So in those kind of systems, we have a much larger area that could be under a cumulative amount of watches and warnings at different time frames. But also, if those storms moving parallel to the coast, we have larger areas under watches and warnings at the same time because there's a larger uncertainty, especially if the storm's moving kind of angular to the coast but approaching the coast. You have a small deviation from the track can make a big difference in where this makes landfall. A good example was back with Hurricane Charlie. The Tampa Bay area was under a hurricane warning. The storm deviated just a few degrees motion to the right, and they never received any hurricane conditions. However, the major hurricane conditions were experienced down in Port Charlotte, which is a large distance if you're driving by car, but the storm angle of approach only changed very slightly. So one of the reasons we issue the warnings the way we do, we pick the time, the location, we try to stick with it as best as we can to maintain continuity with the previous watch warnings. We don't want to add and subtract watches and warning locations. It creates a lot of confusion. But when we do issue these watches and warnings, we want to anticipate possible changes. So if we think there's going to be a possible shift to the west or to the east, we might build that in when we issue the initial watches and warnings. We also think about the vulnerability of the area potentially affected. Is that area prone to storm surge? Is it more prone to areas that need large evacuations? Things like that are also thought about when it comes to some of these decision makings. Time of the day or day of the week is also a consideration, because if we issue for example, a hurricane warning in the middle of the night, everyone's asleep, so that's kind of eating away at the lead time. You want to issue it before that time, so people have a heads up, say, hey, you need to get preparing starting tomorrow morning, so people aren't caught off guard. So we coordinate internationally watches and warnings. That was showing you examples of we make the decisions, and we make sole decisions with talking to emergency managers about U.S. watches and warnings, but internationally, we are the regional specialized meteorological center through the WMO, World Meteorological Organization, on we inform the public about the watches and warnings, but they're making the decisions on issuing the watches and warnings. They will collaborate with us on some of the decisions on whether or not they should be included, but they have to make the final call with respect to their respective country or jurisdiction. And so we have a large area, a lot of different land masses, and a lot of different phone numbers of folks we have to talk to, both in the Atlantic and the Pacific, when there's storms threatening those locations. And you can see the picture, the top right-hand corner of the screen. That's a picture of the Hurricane Specialist Unit operations area during the approach of a major system. So it's kind of an all-hands kind of a deal. And the very background, you can see some of the media folks in their conference room there. So there's a lot of folks that have to coordinate, a lot of moving parts. And you can see some of the storm surge folks sitting right there next to the forecaster. They're trying to coordinate the watches and warnings, not only for wind, but for surge, and Phil's going to talk about that here in a little bit. We also have, a lot of you are probably familiar with this potential tropical cyclone advisories. What it does is it essentially is the same kind of product suite that we have for regular systems, except for it's before a system actually is genesis. And Brad was talking about genesis before. Let's say, example, a storm doesn't have a well-defined center yet, but computer models are very confident that it's going to happen, and this system is going to most likely impact land with a tropical storm or hurricane conditions. It allows us the ability to say, well, hey, this storm hasn't formed yet, but it's going to cause, it's in a situation where we have to issue watches and warnings if it's going to reach land as, let's say, a tropical storm. And so we can issue potential tropical cyclone advisories to issue watches and warnings before the system ever forms. And this is used a bunch of different times. Using 2017, 18, 19, and actually in last year, Isaias as an example, we issued potential tropical cyclone advisories for that system before it reached the Leeward Islands, because it had already had a very large wind field of tropical storm force winds, and it had a high confidence it would close off before it would reach the Eastern Caribbean. Even though it actually didn't, it still gave everybody a heads up that they were going to probably get tropical storm conditions, which they indeed did, as the wave moved through the area before it formed. And so very similar for tropical cyclones versus potential for as far as our watches and warnings. Watches means winds are possible within 38 hours, warnings expected within 36 hours. And the standard suite of products, like I mentioned, is the same for the potential tropical cyclone. One question we do have, and you can chime in through the question GUI there, is this service needed for the marine community? And so we don't have potential tropical cyclones of watches and warnings in the water areas right now. A lot of times it'll be handled by a gale warning or storm warning in some instances. And so if you could maybe provide some feedback if that's something we need to coordinate with making a watches and warnings and advisories over the water areas. And that concludes our portion of the discussion. So if you folks have any questions or comments, feel free to use the GUI to ask those questions, and Brad and I will be happy to answer those for you.
Thank you so much, Andy and Brad. That was a great presentation. Once again, if anybody has any questions, please go to your GoToWebinar control panel and enter them into the questions tab. And right now, I don't see any. We'll wait a couple more seconds to see if anything comes in. And I'm hearing crickets. All right, if anybody has any questions that they would like to address to Andy or Brad, feel free to put them in the questions box and maybe we can pick them up at the end of the webinar. Thank you again, Brad and Andy. That was a great presentation. We appreciate your help and time. So we'll be moving on. Our second presentation today, it is my pleasure to introduce the Operations Manager for the Storm Surge Unit, Lieutenant Phil Manoogian at the National Hurricane Center. He will spend about 15 minutes discussing storm surge products and services with about 5 minutes for questions at the end. Phil, let me give you the presentation and the floor will be yours.
All right, good afternoon, everybody. Assuming you're on Atlantic time. Thanks for let me get this set up for you here. All right, Lexee, does it look okay to you?
Phil, I can see you and your presentation. You're good to go.
All right, good afternoon, everybody. Lieutenant Phil Manoogian here from Hurricane Center Part 2, we'll call it, as we're all working telework, especially in the off season. Though I will say for most of the season, the Storm Surge Unit and some of the hurricane specialists can continue to work remotely from home. So continuity of operations for us goes pretty well. I'm going to talk to you guys today about storm surge. This is not a concern for you if you're at sea. If you're at sea already, the water gets higher, you just float on top of it, not a problem. The point of today's 10-15 minute chat is going to be how do you mitigate the hazard of storm surge when you're tied up, getting ready to leave, or you're in shipyard, you have personnel or hotels near the water, especially along the Gulf Coast. This presentation should help show you how to understand the risk and make a plan around it to keep you, the ship, and your crew safe. This year was a bit active for a lot of people, so I'm sure some of you are hearing this for the 15th time and others for the first. So first of all, what is storm surge? The hurricane winds push water onshore. You can see this in a pool. If it's a windy day and you have a pool in your backyard or your local pool, the water piles up on one side from the other just because of the surface wind. A lot of people think it's the central pressure of a hurricane. It's not true. It's only about 3 to 5% of the total water rise. So storm surge, we tend to think of any water due to the winds of a hurricane that are getting pushed onto normally dry land. So if you're thinking of like the Everglades in Florida, debatable. It's often dry, but it's also kind of marshy and underwater, so it's not as big of a deal. Downtown Miami, Tampa, over the seawall, that would be considered storm surge. So what products do we have for you to make your best decisions? That's what this talk is going to be about. I'm not going to go into too much detail on case studies or anything unique like that, how exactly we make the products, but what exactly you should use and when. So this is an upside down triangle. I think it should be flipped, but you'll see why in a second. We're going to read it bottom to top. So 5 days out or longer, including today, in response to a hurricane coming in, say, August, you would use something called the MUM, or the maximum envelope of water for any direction of storm, specifying an intensity, but you have no idea where it's coming from, when, what time of day, what tide cycle. You just know if there's a Cat 5 coming, how far could the water go? And then we can say, all right, there's a storm that exists. It's about 2 to 5 days out. We know it's not coming from the east. It'll probably be from the southwest because it exists and you can see it. So you can use something intermediate. You can use a MUM or a meow. These are all sort of cat references. I'll show you what they mean in a second if it sounds odd. And then this is the one that everyone really likes, and this is our best stuff here. The probabilistic storm surge flooding map and watches and warnings and the public graphic advisory. So these are the storm specific information. So the bottom two are pre-computed. The top ones in the red area are storm specific. So here's what pre-computed looks like. The maximum envelope of water we do by basically taking about 1,000 storms with a specific category, with a specific forward speed and direction of landfall, and then we just run it all along the coast. And that gives us sort of, what if you get a storm from this direction, but we're not sure exactly where it's going to make landfall, what will it give you? And that's nice, but what if you're not even sure what direction landfall you're going to get? You can add, so I don't have a graphic for it, but if you take these lines and shift them about 90 degrees to the right and make them come out of the southwest, from the south, from the south-southeast, and you do this a ton of times, you vary the size and everything, well, what will happen is you basically get this. This is a maximum envelope of water. It knows no specific direction or forward speed or tide level. It accounts for all of that, and all you say is a storm category. These are available for you right now. You can search for this. It would be searchable under something called the national MUM, or the maximum of meows. And And it's good for risk planning. It's good for understanding the risks of building to appear generally without any storm in mind. This is to be used well before a storm. This is only a risk map, and not any single storm can make the footprint shown in either the MEOW or the MOM, these pre-computed models. Now, here's the real-time stuff. So the trick here is the real-time stuff comes out 48 hours prior to the onset of the hazard, and the pre-computed stuff is always available. It's that intermediate part where you're like, well, I think we can do better than pre-computed, but we're certainly not ready for real-time. That's when you would talk to us and we would help you. It's also when you're going to make most of your decisions, you know, getting plans in place, whether to relocate the hotel for your crew. One tool you can use to help pull the trigger on a go, no-go for your crew and for your ship is the storm surge watch warning. For those of you in the Gulf Coast, I'm certain you've been waken up by me and Lexee and the rest of my crew in the storm surge unit, probably at 4 a.m. because the warning and the watch came out. The warning is what gives you a WIA alert on your phone, and the watch comes out a lot earlier than that. So 48 hours to the onset of the threat, storm surge in this case, you're going to get this bottom image over here. And then once we're more certain about the aerial extent of the location of over 3 feet of inundation somewhere, which is what is sort of the criteria here, where the danger of storm surge is likely, we're going to light it up. And you can see in the top image, the watch extends further, less certain in that area, whereas the warning is in an area we're more certain of having over 3 feet of ground inundation, cutting off local infrastructure, roads washed out, buildings being destroyed. This is a great go, no-go tool. So if you're talking to the Marine Ops chief, or you have people above you you have to answer to, a watch and a warning, both from the wind side and the water side, are the tools to help you say, look, we do need to go. We do need to make an action to change something. These may stay in effect after the storm. So this isn't like dropping a water balloon and it splashes and water is everywhere and then it's gone. All that water that goes onto normally dry land has to then come off of normally dry land. The absorption rate of storm surge is very low. So though the storm may have passed, there's a couple factors in place. Water hasn't receded right away. We saw this in Laura on the Texas-Louisiana coastline, where water remained feet high for days, and it's salt water. It's not the kind of water you can just sort of make do with. Like, I can hike through the Everglades in fresh water. In fact, Dr. Landsea just did so recently with his son, 3 days through the Everglades. Not a big deal. Salt water and storm surge is not something you want to be in. All right, so the potential storm surge flooding map. This thing looks a lot like the first 2 graphics I showed you, but this one is storm specific. Hurricane X isn't real. We ran it as a simulation years ago, and I have the graphic here. And what this does is it shows you the flooding, the reasonable worst case flooding from a single storm. So in this case, when Laura came through, we would show the flooding from Laura. But it isn't exactly the flooding. It's a reasonable worst case. So you can think of it as a 10% exceedance, or a 1 in 10 chance of occurring. Or better, there's a 9 out of 10 chance the flooding we depicted in this graphic is too much. It won't happen. There's a reason we do that, because if we did a 50% exceedance, well, half the time we'd be right and half the time we'd be wrong. So if half the time your ships got washed out to sea and your crew perished and half the time they didn't, I don't think you would accept that risk, and neither does the Hurricane Center. So we do a reasonable worst case. If we did a 0% chance, that's saying this will never happen, which is not usable. So we give a footprint that's no one storm can make, but it is totally possible from the storm in question. Here's an example of what that looks like pre-storm, sort of forecast mode, and after storm. On the left image, Hurricane Florence in 2018, the left image was our storm surge flooding map from Advisory 48. This is about 36, 48 hours outside of landfall. And this is where we said the water could go. Note Newburn here, sort of in the center left side. On the right is where we ran the model, but in reverse. So instead of saying, here's a model and then give it 1,000 extra tracks left and right, change the size and speed a little bit to account for uncertainty, we actually ran 1 or 2, but looking backwards with the actual track, knowing where it actually went. And you can see the footprint of the water is exceptionally close. The values are lower a little bit, And the values, if you can see here, orange is greater than 6 feet above ground, red is greater than 9, yellow is greater than 3. Anything over 3 is a warning. Anything over 3 lifts up cars, washes it away, can destroy buildings. And so though the heights were a little lower, the above ground, still incredibly devastating storm surge area, and the area that it covered nearly exactly matched our forecast, though the actual height above ground was a little different. Why is this important? We can put assets places much closer to where the storm surge is likely to be. Response time is quicker, or we can have people realize they don't need to move, that there is very little risk to storm surge and where they are. Maybe the hotel for your crew is about 15 miles north of New Bern and isn't within a storm surge zone. But if you just read a text product, you'd have no idea. Here's a different thing we're working on this year, and purely to help with communication. So all of our products are just to communicate a risk we know exists. The last few products have shown you an aerial extent, rivers overflowing, bays moving onto land. This one is something more of something you can tweak. The other things you can click through and zoom in on. This one is a grab and go image. It's great to communicate what the general risk is. But if you notice, this red line here does not move inland any further than the coast. It does not show you how far inland. It doesn't show you an aerial extent. And it shows you the peak surge, hence the name peak storm surge graphic. So not everybody between Dauphin Island and the Okaloosa-Walton County line here in Florida and Alabama will see 4 to 6 feet, but the peak could be 4 to 6 feet somewhere in this area. I know this storm specifically was troublesome because it swung itself left to right across the coastline here at a very short lead time. Models finally got a grip on it really close in. So this would be something we want to check back on. We don't take one forecast and stick with it for the whole hurricane because, we get better information, we make an updated forecast. And here's something I think is really important for something that could be really important. I haven't quite tested it out throughout a season yet. I know that the NOAA ship tracker has updated itself and you can now overlay layers. Storm surge is not included on this, but as the NOAA Corps liaison to the crew and the OMAO fleet, I want to make sure you're aware of it, that you can produce weather layers on top of your ship's position. Probably pretty nice at sea, especially if your ship's position is updating properly. No storm surge, but it does do wind, and it shows you the colorful exceedances, like the likelihood of exceeding tropical storm 50 knot and hurricane force winds at sea, as well as a cone graphic. But make sure that you check the timestamp. These types of services where they take data from somewhere else, overlay it, show you all kinds of things, all the layers of data have different timestamps, and you wouldn't want to be looking at something wrong. If you need a case study as to why that's important, look at El Faro. They had old data. Now, you may not be able to see the timestamp on the new NOAA ship tracker very well. If you're not sure, just go to the Hurricane Center site. Hurricanes.gov is going to be updated immediately. If you notice anything wrong on that site, send me an email. We make sure 24/7 it's updated properly. That was a lot. I didn't have a whole lot of time, but I would love to take any questions that you can provide me. Either through the chat here, I think in the text chat would be great. I'm also, of course, available 24/7 throughout the hurricane season and normal hours otherwise. Send me an email, and if you find that your ships or your marine centers, Atlantic, Pacific, need something like this, let us know. We can always put on something a little more specific to your cruise. Thank you.
Great, thank you, Phil. That was super informative. Looking at the question box, I don't see any at the moment, but as I sort of scroll through, we can wait a couple more minutes or seconds, I suppose, before we move on. And just like Andy and Brad's presentation, if any of you come up with a question later today and would like to ask Phil or Andy or Brad or any of the other presenters, please feel free to put them in the question box and we can address them at a later time. So, as I'm switching presenters, let's see here, bear with me. All right. So thank you again, Phil, for your presentation. We are going to move on to our third presentation. It is my pleasure to introduce the Tropical Analysis Forecasting Branch Chief, Dr. Chris Landsea at the National Hurricane Center. He will spend about 45 minutes on his presentation regarding marine forecasting for the South Atlantic, including the Caribbean and Gulf of Mexico, with about 10 minutes at the end for questions. Thank you, Chris. The floor is yours.
All right, sorry. Lexee, can you see my screen and hear me?
Yep, Chris, I've got you loud and clear, and I can see your slides.
Wonderful. All right, great, thank you. So again, my name is Chris Landsea, and I lead a group of 18 marine forecasters down at Miami. You may not know that we have marine forecasters at the National Hurricane Center, but indeed we are the largest component of the National Hurricane Center as far as number of people. And so wanted to get a chance today to discuss with you our products and services as you do your roles as NOAA vessel operators and folks working aboard the NOAA ships. So that preamble show what our mission is. So what we do, try to do every day, not just during hurricane season, but we keep mariners safe by providing analysis and forecasts of winds and waves. And we do issue warnings over the open ocean so that mariners can stay safe and safeguard their property on board their ships, whether the property is cargo or oil or people or, you know, your cases, maybe research equipment and researchers. So we don't do coastal, we do essentially blue water, so 60 nautical miles and further off the coast. Why is marine forecasting important? Of course, you all know this much more than I do. I'm a recreational boater, but I've never been serving aboard a large vessel for much time. But this video really kind of brings home to just about anyone why it's important for good forecasts. This is an example from a cruise ship rounding the south end of South America several years ago of really, really bad decision making because they were going with waves that are 30 to 40 feet. And then the captain and crew turned the ship 90 degrees and they started getting broadsided by very tall, steep waves with a very short period. And it got very dangerous quickly. A lot of people got hurt, some seriously hurt. You can't always get a perfect forecast, but you know, one can anticipate that you're going to have impacts aboard the ship. And so that is your responsibility to keep people safe and to also safeguard your cargo. The captain and crew of this ship did not do that, obviously. There was no warning for everybody, hey, hunker down, it might get a little rough. No. Instead, everything starts swinging back and forth. So hopefully it's never been like that aboard any of your ships. So our responsibility, similar to the hurricane specialists, has an international component. So we are part of the International Maritime Organization, the IMO. And as you likely know, every square inch of the oceans, there's a country responsible for providing free wind and wave forecasts and warnings. And so our area of responsibility for the National Weather Service's component is both the North Atlantic as well as the Pacific. So the folks out in the Honolulu that get the good fortune to work at the Honolulu Forecast Office, they do the Central Pacific. The Ocean Prediction Center, high latitudes of the Pacific north of 30, and the North Atlantic north of 31. That's done at College Park. You'll get to hear all about OPC's products and services from Darin Figurskey. And this is our area. So it's the Eastern North Pacific, the Caribbean Sea, Gulf of Mexico, and tropical North Atlantic. So that little teeny area is 10 million nautical square miles. So it's a massive area of responsibility that we do our best to provide information for every day. And there's lots of customers out there. This always astounds me when I take a look at marinetraffic.com for those ships that have AIS transponders on board. Just amazing how many hundreds of large vessels that are out there, whether they're red, which are the oil tankers, green, which are the cargo ships, light purple, which are the giant personal yachts, and dark blue are the cruise ships. So obviously this is not today because the cruise ships are moving around here. So our area, both the East Pacific along the coast of Mexico and Central America, through the Panama Canal, Caribbean Sea, Gulf of Mexico, West Atlantic, that's also your area of responsibility that you're doing, whether it's hydrographic missions or fishing monitoring or other research activities. You're out in the same waters. So I'm hopeful that you're using our forecasts. And I want to go through some of our products and services so that you can use these to keep yourself safe as you're out over the open oceans. So Brad went through some of the climatology of tropical storms and hurricanes and locations that are most at risk. So I'm not going to rehash that, but I did want to talk about wintertime conditions. These colors indicate areas of gales that we tend to get in the TAFB, Tropical Analysis Forecast branch, here in Miami. And so you can see in the Caribbean, north of Colombia, a very, very common area of gales. Down near Veracruz, very common area as well, because you get the funneling of cold front winds along the mountains of the Sierra Madre Orientals. There's also common gales just east of Florida, occasionally between Cuba and Hispaniola. And then just like we're going on today, we've got a large area of gales south of Bermuda as well. So those are the areas. So in the wintertime, those conditions are caused when it's Colombia by a large pressure gradient between the Bermuda High and the Colombian Low. In the Gulf of Mexico and the West Atlantic, that's going to be caused by cold fronts that are coming across. And rarely you may get a nor'easter that starts farther south and produces those conditions as well. But those are the geographic areas that are susceptible to gales in the winter and spring. So what are some of the tools that we use on a daily basis to do our marine forecasting? We start with the observations, the measurements. And we certainly do get ships at sea that are sending their information, whether it's the wind speed, wave height, the wave periodicity and direction, of pressure measured, but we don't get very many. Of all those hundreds of ships that I showed you, we only get about 5% of them are in the VOS program, the Voluntary Observing Ship program. I believe that most or all of the NOAA ships are in that program already, so we're getting your measurements, which is great, because more information that we get allows us to make a more accurate assessment of what's going on now and for a better forecast into the future. We also make really good use of moored buoys and drifting buoys operated by the National Data Buoy Center and other organizations. And we also have remote sensed measurements of what's going on at the ocean. So the wind barbs in these colored swaths are from scatterometers. US doesn't have any scatterometers right now, so we rely on the good fortune of being able to access the 3 scatterometers the European Space Agency has. And there's also altimeters, which is another radar in space that gives us wave heights essentially accurate to the nearest foot, which is amazing that you can get such capabilities from in space. We also have a tool which was launched a few years ago, which is the next generation geostationary satellite. And so this is about $1 billion platform, and it's essential. We could not do our job, and the same with the hurricane specialists. They could not do their jobs at all without the information you're getting from the satellite imagery. And so this is a critical part of our operations during hurricane season and during the winter and spring as well. Some additional tools that we use for our forecasting are different computer models. On the left is an example from the Global Forecast System. And so that's the US National Weather Service global model. And so one thing it produces are 10-meter winds. And so that's the basis for much of our forecasting. We also have access to other global models, for example, the European Center for Medium Range Weather Forecasting that Andy had mentioned as well. And so we'll take that information and blend it together as we kind of see fit, knowing the biases inherent in these different forecast models. as well as at the near time, some of the observations that we're seeing from buoys or from ships or from scatterometer. On the right side is an example of a wave model. So typically wave models are driven by the winds from global or regional models. And so that provides the wind waves and swell information, as well as the periodicity of those waves and the wave directions. So it turns out we actually run a wave model in-house based on our wind grids. So we have the wind grids that we employ for our forecast information from now through the next 6 days. And we use that to drive our own wave model. So the information we provide is supposed to be consistent between the winds and the waves that are generated by those winds. And then lastly, we use a system called the Advanced Weather Interactive Processing System, or AWIPS, to take a look at the observations, interrogate the satellite imagery, investigate the different computer models, and then also put all that together. And so we use a gridded database called the National Digital Forecast Database, and we're using a tool called the Gridded Forecast Editor, a graphical forecast editor, where essentially we have winds and waves and warning information spatially from now through day 6. And so it's a really wonderful workstation that we use, and also used by the local weather forecast offices. So those are some of the tools that we use. So it's a combination of a trained meteorologist, understanding the tropical weather and marine weather, using the observations that are available, as well as the computer model guidance. So let me go through some of the key products and services. And again, I'm hopeful if you're down in the Caribbean or over the open Gulf of Mexico that this could be useful for you for planning your routes and your mission. The first product is more of an internal one. It's actually for Andy and Brad and the other 8 hurricane specialists, where we are examining the satellite imagery, the loops, and to determine a best estimate of where the storm is and how strong it is. Turns out that only about half the time are there hurricane hunters that are in the storm to measure what's going on. So a lot of times we're providing that first guess of where the storm is and what are the peak winds, or what is described as intensity. And so that's a key component for what the hurricane specialists are going to be providing on the hurricane side of things. Another aspect is, how do you get weather forecasts over the open ocean? So I'm going to start going through some of our products. So it really depends on what kind of capabilities you have on your vessel. Certainly, there are a lot of vessels out there today. I know that there's a lot of Coast Guard cutters that only have the radio fax and the Global Marine Distress and Safety System, so they can get the text products. Whereas other ships, like cruise ships, when cruise ships are running, that everyone on board has high-speed internet access. And there's a lot of ships in between. I would be curious of what the general capabilities are of all the NOAA vessels that go out over the open ocean. So this is a listing, and again, we're going to go through some of the products that are available on each of these types. So the foundation for all our forecasts is a weather map. We call it the Unified Surface Analysis, and it's a combined product between 4 different agencies. TAFB down here in Miami, Ocean Prediction Center for the high latitudes of the oceans, Honolulu Forecast Office, and the Weather Prediction Center, also in College Park. So WPC does the land areas of Canada and the United States, minus Florida. Apparently they don't think Florida is part of the United States. And if you've lived here a while, you probably understand that's true. So we put it all together every 6 hours to come up with a weather map. And let's take a look at what the one was from 12Z today. So this is the map that our Pathways intern and Maria Torres put together. And it's very active, as is typical for February winter conditions. Very vigorous cold front went through here, and I'm a little chilly outside, but I am outside. And you can see we have gales listed in our area just south of 30 north on both sides of the front, as well as gales in the Gulf of Tehuantepec and a developing gale in the Gulf of Papagayo region. So very active conditions right now. But it's the identification of these features that are causing the extreme winds, the very high waves, that we base the warnings on. And so you really, to make a forecast, you have to understand what is causing the conditions that you're looking at. So, sorry about that. So a key text product that we have is our tropical weather discussion. And so this allows us to go into detail about the meteorology of what's going on now, as well as for the next 5 days. And so this is something that is useful for both Caribbean meteorologists as well as mariners that want to get a little more in-depth understanding, not just to see the forecast that is available in other products, but a little bit more of the understanding of why. So the remainder of the products that I'm going to talk about are the ones that really focus on the winds and the waves and the warnings that we issue. And so we understand that over the open ocean, still today, there's some mariners that just have radio fax capabilities, whereas others have high-speed internet that's very reliable. So until all ships over the open ocean have that last capability, we're going to continue to provide information via radio fax or voice broadcast or medium range transmission of the nav text, for example. It would be nice to go to a very high technology solution today with all grids, but we're not there yet. And so we want to make sure all ships can still access it. And so we'll continue to provide the information in whatever way that ships are needing it. So when we put together the forecasts, whether it's hurricane season or winter storm season, all of our products fall out of our grids. And so we have a gridded domain for both our Atlantic basin and our Pacific basin, and goes out through 6 days. It's got a resolution of 10 kilometers, so about 1/10 of a degree latitude longitude. We have 10-meter winds and gusts, though to show something that goes beyond just 10 meters in a few minutes. Significant wave height and hazards, including the warnings. So just to inform you about how it works between our marine forecasters that are in TAFB at the Hurricane Center and Brad and Andy and the other hurricane specialists. Essentially, the hurricane specialists are driving the bus. That is, they provide the big picture 5-day forecast. And for the marine side, we fill in the details. So we run a script and blend that vortex into our existing wind and wave forecast. And so we want to make sure that what we're doing is consistent with the hurricane specialists, because we wouldn't want to say, okay, there's a, the hurricane specialists are saying there's a hurricane approaching Bermuda, and we're only showing a tropical storm, or vice versa. So we want to avoid that kind of inconsistency, which causes confusion, which causes people not to take the right actions. So one of the mandated products by all large vessels going out over the open oceans is the high seas text forecast. And so we provide this 4 times a day. It goes out through 48 hours, so it's a limited time window, and it does focus on the more extreme conditions. So seas of at least 8 feet and winds of at least 25 knots or greater. So we'll just take a quick look at what's done today. So this was issued just a few minutes ago by Gladys Rubio. So it does talk about an Atlantic warning that I showed you on the surface map. And she's also talking about a few other features as well. So you've got some east trade winds and some swell. The cold front has reached the Caribbean, so that's going to cause some conditions down there. And then just north of Colombia, you have the typical high winds, and also in the Gulf of Mexico. We understand that text products are hard to read and digest. And so this is becoming, it's still mandated, but it's becoming kind of a secondary option for folks. And understandably, it's understandable why. So another text product that goes into the forecast in more detail are our offshore zones. And so this covers the Caribbean, the Gulf, the West Atlantic. We also have a separate section for the East Pacific. And again, for each of these polygons, it has more detailed information as well as any warnings that are in place. The nice thing is we do have a GUI that allows one to interrogate a specific region that you're interested in. So let's say you're going to be doing a research cruise over the central Gulf of Mexico. You just mouse over that and you get a nice summary of the 5-day conditions. And so In this case, it's got winds and waves. There's no swell, as is typical in the Gulf of Mexico. But if you're looking out over, say, just north of Puerto Rico, that's got a gale warning in place. And we do indicate where it's a swell if the wind waves are not accounting for the entire or the majority of what's going on for the significant wave heights. Another one that we provide is NavTex. Actually, Coast Guard did a survey about 2 years ago now, seeing if any ships still use the NavTex text product, and I was shocked at how many private vessels, private companies are still using this NavTex. So it is not going away. Coast Guard's going to have to maintain those medium-range transmitters for a while longer there. Another ones are the voice broadcasts. It's similar to our offshore zones, but a little less detailed. I'm not sure how many people use these high-frequency broadcasts, again, by our colleagues in the Coast Guard, to listen to the broadcast. I'm not sure if there's a lot of users to this particular product anymore. And then marine radio facts. You know, this technology has been available for decades, and it's still quite important for probably a majority of the cargo ships, for example, out over the open ocean. And so we rely on the help from the Coast Guard for maintaining transmitters in New Orleans, Point Reyes in California, and in Hawaii. And so they'll be transmitting our products and the Ocean Prediction Center products. So one of the first ones we focus on are the features. That is, what are the meteorological conditions that are going to be causing the winds and the waves? We issue these surface progs twice a day. One set covers the West Atlantic, Caribbean, and Gulf of Mexico. Another set covers the East Pacific, and it does day 1, day 2, and day 3. So anything that's going to be causing winds and waves or cause us to issue warnings, we'll indicate as a feature. Let's just take a quick look of what GLADIS has done today. So in 3 days, so this would be on the 2nd on the 5th at 12Z, that front starts stalling out in the central Atlantic, and yet another cold front emerging off the Texas coast. But none of these are expected to become gales, because we would have put possible gale to accompany that. So when we switch then to wave forecasts, the first is an assessment of what are the significant wave heights now. And so what we show is conditions that are occurring, and we show everything in feet. So that's an important point. Is we understand globally a lot of mariners use meters. We are still using feet for all of our official products. And again, take a quick look at what GLADIS did this morning. So a huge area of high winds, high seas over the Gulf of Tehuantepec with that Tehuantepec going on. Still quite large seas over the eastern Gulf of Mexico, 10 foot, and then almost 20-foot significant wave height close to Bermuda right now. So very active conditions that we're seeing presently. And then we go to the forecast of the winds and waves. And again, this is coming right out of our gridded database of winds and waves that we've massaged, and we've put in our input into making the forecast as accurate as we can using a variety of different sources. And so this again is a day 1, day 2, and day 3 forecast. It's issued twice a day, and again for the West Atlantic, Caribbean, and Gulf, and then a second set for the East Pacific. And then one last time, we'll take a look at what GLADIS did. This shows the winds and waves, and this would be for the 5th at 12Z. No gales anticipated in 3 days, which is nice. And peak seas of about 11 feet just north of Colombia and 12 foot east of Bermuda. But fairly quiet for this time of year is expected in 3 days. We also have wave periodicity and direction. As that video really highlighted, certainly the most dangerous conditions are tall, steep waves hitting the broadside. So this is information that provides for the dominant wave of what that direction is and what that periodicity is. So if it's, for example, a long swell coming across the equator from thousands of miles away, it'll show up as a fairly long period, say 15 to 20 seconds. Whereas if it's almost all wind waves, it's going to be just a few seconds in duration. This is issued twice a day, and it's focused on day 2 and 3 forecasts. During the winter, A few years ago, we had an opportunity for a slot on the radio fax. So we made this graphic to fill that radio fax slot. And essentially, it's a snapshot of any warnings that are in place 48 hours from now. And this is issued 4 times a day during the winter season. We'll just take a quick look. I'm not sure if there's anything on Gladys's today. No, the answer is none. So both at Tehuantepec is going to be gone by February 4th at 12Z. During the hurricane season, we replaced that with a tropical cyclone danger graphic. And so this is derived from the wind speed probabilities that Andy Latto talked about. And so it shows 2 areas of dangerous conditions. One is the light hatch, which is a 5% chance of tropical storm winds. And the dark hatched is a 50% or more chance of tropical storm winds. And so it depends on your risk threshold. If you want to make darn sure that you avoid any tropical storm winds in your vessel, you'd want to stay outside of that light hatched area. So one thing that came up just a week and a half ago, Darin and I got a chance to talk with the folks at MyTags, which is the Maritime Academy near Baltimore. And they were still teaching their mariners the 1, 2, 3 rule about tropical cyclones. So I encourage them to no longer do that. You know, just use these products, which account for the size of the storm, how fast it's moving, and how strong it is. Hopefully, as we progress, we can enhance the new products and services. So one can go beyond just a simple rule of thumb when it comes to potential loss of life. So one thing I'm excited to show about is the way we're trying to modernize and provide information to folks going forward. So if one has even low bandwidth internet available, say you're in a remote port in Mexico, so you have some internet, maybe some Wi-Fi, but it's not high bandwidth, you can access this information. So on the right, it shows snapshots every 12 hours of winds and waves. So the winds are in wind barbs, and the colors indicate significant wave heights. On the left, it shows a depiction of different thresholds of winds and waves, just like our high seas text product does, but it shows it graphically. And so this was a case where a very similar strong cold front from last winter, where gales were coming across the Western Atlantic. So we call this the Marine Composite page. It's on our website. The website is there. And just today, we had an opportunity to enhance it. We've been working on this for a couple years. And at the request of many mariners that we've had at our mariners workshop that we host every March, they wanted 30-meter winds. They wanted 50-meter winds, because some of these massive cargo ships and cruise ships have a profile that are 30 or 50 meters above the ocean surface or more. And so we essentially take our operational wind grids and derive what the 30-meter and 50-meter winds are that would match those 10-meter winds. And we also are providing not only a significant wave height in feet, like we always have, we have new graphics that show it in meters as well. And so if you are more comfortable on meters, that's available for you. And then lastly, we're providing for the first time a cumulative maximum wind over the next 5 days. That is, how strong is it going to be, likely, at least forecast, over the next 5 days. So you all are the very first to get to see this, because we literally pulled the trigger on this just yesterday. And so we can take a look. What are the winds going on? Actually, let's look at the wind barbs, and we'll bring up the wave heights in meters and our features. And so this is the forecaster the definition of what's causing the winds and waves. So again, this is from 12Z today. There's that strong cold front, gales on both sides, and we can go forward in time as that cold front progresses eastward, and the gales move with it. In a couple days, the gales disappear, and you can see those oranges and yellows are leaving our area of responsibility, and so the wave heights are diminishing quite a bit. So let's just go back to the initial time, and we can take a look at So these are the 10-meter winds that we've been providing forever. And here are the 30-meter winds. And here are the 50-meter winds. And so if you're interested in, winds above the standard 10-meter or 33 feet location there, we're making those available graphically. Also, if we want to look at, well, what are the strongest winds at 10 meters expected over the next 5-day cumulative, we just click on the max 10-meter wind. So you can see over the next 5 days, if you're in a ship that a gale is going to be problematic, you'd want to avoid any of those purple regions for the next 5 days. And then lastly, if you want to look at waves in feet, there's waves in feet, and here's waves in meters. And so it's the colors are the same essentially, but just the units are different there. So again, I'm excited for the opportunity to share that with an audience for the first time that may get some use out of it. So one last thing is we're really gratified to see when ships are making use of our forecasts. And that is most evident during hurricane season when a strong hurricane is going across the Gulf of Mexico. And so this shows, back to it. No, not very easily. So that showed I'll force it to. That showed a little video of ships practicing good heavy weather avoidance during Hurricane Delta. All right. One more time, so you can watch it scroll through. So you can, just from marinetraffic.com, you can see the ships moving out of harm's way as hurricane approached. Of course, Louisiana, that was the hurricane magnet last year. So that's great to see when almost all ships are doing their best to stay out of harm's way. So those are the products and services I wanted to talk to you about, especially to point out the new capabilities in this marine composite page. One thing I want to make sure you're aware of, because you may not, is that we provide the Coast Guard with spot weather forecasts, whether the Coast Guard is dealing with a man overboard or a missing ship or a downed aircraft or law enforcement activities or an oil spill, anything that they need a specialized forecast, we can provide them. And so we work sometimes with District 7 in Miami, District 8 in New Orleans, District 11 in California, District 14 in Honolulu. It turns out that, I don't know if you know this, but the Coast Guard doesn't have a weather forecasting component to them. So by agreement that's signed every 10 years, the National Weather Service and NOAA provides forecasts and support services to the U.S. Coast Guard. And I know that you all have a special relationship with the Coast Guard because you train with the Coast Guardies, the Coasties, at Coast Guard Academy in Connecticut, and many of you get a chance to get aboard the Eagle and train with them over the open as well. And so we've really been working this relationship to assist them in their life-saving operations. And this graphic showing their search and rescue regions for the various districts, and over top of it is all the different hurricanes that we provided briefings for. We gave them 88 live briefings to District 7 and 8 during this horrendous hurricane season. And so they use that to pre-position their ships and their aircraft, make decisions about evacuating their personnel, and also the recovery aspect if people needed rescuing after the fact. So that's a relationship we're going to continue to work toward, given the National Weather Service's emphasis on decision support services. Lastly, did want to talk about social media, that we're trying to provide more information through that approach. In fact, in Twitter, anytime we have a warning that's issued, there's an auto tweet that goes out right away. So that's one way to get the word out to mariners that there's a new hazard that's available. And then just to wrap up then, we have 18 men and women that work 365 days a year to keep mariners like yourself safe. We can't steer the boat for you and make decisions, but what we aim to do is provide the best forecast information possible. And so the hurricane specialists are busy 6 months of the year with operational forecasts. We work closely with them to make sure our marine forecasts jive with what they're providing. And then 6 months of the year, we're on our own doing the best we can to provide information. So if you do ever have any forecast needs, there's our website, or you can just go to hurricanes.gov and then click on marine. And we've got forecasters staffed 24 hours a day. And so if you're in our area of responsibility and you have a forecast question, you could just call us even. You would surprise our forecasters, I'm sure, because we don't get calls that often. But I hope that gives a nice overview about our products and services at the Marine branch of the National Hurricane Center. Thanks. Any questions?
Thank you, Chris. I'm just taking a peek at the questions tab, and it doesn't look like we have any popped up right now. That could change. So we can stand by for a few more seconds to see if anybody wants to add any questions.
So while we're waiting, I did want to say thanks to Captain Kurt Zegowitz. He was the one that suggested putting together this marine weather workshop for NOAA personnel. And also, one thing I'm trying to do is get our marine forecasters aboard the NOAA ships. And thank you to Captain Dan Simon for getting Landsea Ramos. Dr. Ramos was able to get aboard the Ron Brown back in May 2019. And I was hoping we could get more forecasters aboard the NOAA ships, and then the pandemic happened. So once that pandemic ends, I will be trying again to get forecasters aboard some of your ships.
Yeah, hopefully that'll work out for you guys. Just don't forget your meglazine. All right, Chris, I don't see any questions in the questions box. And like I've been saying throughout the day, if anybody has any questions, just throw them in there. We'll respond to them either at the end of the presentation or in the future. So we are going to move on to our final topic. Give me just one moment to switch around the presenters. Oh, it looks like we got Darin already set up here. One moment. Okay, so for our fourth and final presentation today, it is my pleasure to introduce Operations Branch Chief Darin Figurskey at the Ocean Prediction Center. Darin will spend about 45 minutes on his presentation covering marine forecasting for the North Atlantic. So Darin, the floor is yours.
Lexee, thank you very much, and appreciate the opportunity to be here with all of you this afternoon. So again, I'm Darin Figurskey. I'm the Operations Branch Chief at the Ocean Prediction Center of the National Weather Service. And just to kind of lay out a little bit about where the Ocean Prediction Center sits in the National Weather Service, the OPC, along with the National Hurricane Center, are part of the National Centers for Environmental Prediction. And there are 9 centers that predict things ranging from severe weather, space weather to include, coronal ejections, mass ejections from the sun, Aviation Weather Center, which handles aviation, significant weather events. We have the Climate Prediction Center that looks out at long-range forecasting. The Weather Prediction Center that does forecasts, particularly for the medium-range forecasting, helps with Alaska, does some heavy rainfall and snowfall forecasting, coordinates with offices around the nation to help issue consistent, accurate weather watches, particularly for winter weather and sometimes with flash flooding. And then we have our NCEP Central Operations, our Environmental Modeling Center, to make sure the data flows well and the models run right. So again, the Hurricane Center and the Ocean Prediction Center, just part of 9 centers at NCEP. And Chris covered a lot of information about products and services. And just to highlight again where the Ocean Prediction Center's area of responsibility lies. In this graphic here over the Atlantic, it's the area in the couple of shades of blue, offshore forecast extending off of the East Coast from 31 north into the Gulf of Maine, extending east to about 250 nautical miles, about equal to the exclusive economic zone. And then our high seas forecasts go out to roughly about 35 west. And we also do FACS charts, as Chris just described, going out much farther to the east there over to Europe. On the Pacific side, similarly, in the shades of blue here, we have our area responsibility over the Pacific, 250 miles offshore, thereabouts for the offshore forecast from the west coast of the United States, and our high seas forecast, where our authoritative warnings go out to 160 east. There's a little bit of overlap with our forecast responsibility with offices in Alaska region, because we do cover for our high seas forecasts areas in the Bering and in parts of the Arctic. And as Chris mentioned before, his office there in the green shaded area, and then the Honolulu office covers their part of the tropical Pacific there in purple. When it comes to the med areas, the World Meteorological Organization has divided up the world into these meteorological areas, and we forecast combined with the Hurricane Center and with Honolulu, we do med areas 4 and med areas 12. Med area 16, just off the coast of South America, was part of our collective responsibility. The Hurricane Center used to do that up until about 2 or 3 years ago, when that moved to the responsibility of Peru. So kind of why do we do what we do? And I think it's kind of important to put in context the reason why our mission of safety of life at sea is so important. And this is just a heat map, courtesy of a couple of senior forecasters, Tim Collins and Jim Kells at the Ocean Prediction Center, who maintain our hurricane force climatology, showing where the hurricane force lows occur in the Atlantic. And this was from a year period from June 2019 to May 2020. Of course, in the Gulf Stream off the coast, you'd expect to have some development there. A really bright spot off the coast of Greenland, tipjet activity and lows really ramping up and deepening in that area. But there are a lot of hurricane force lows in the Atlantic, an average of 45 each season, and in the Pacific. There are also a number that occur there every year, extending particularly across areas near the Great Circle Route, and where there's a lot of vessel traffic coming from the Far East through the area near the Aleutians and into the northwest part of the United States, in many cases headed toward ports, not just in Seattle, but down toward Los Angeles, Long Beach. Average of 36 occurred there. And again, this is just a map from June 2019 to May of 2020. So every year, there are in both basins that the Ocean Prediction Center forecasts for nearly, not quite, but nearly triple figures in the number of just hurricane force extratropical lows. That's not to mention all the storm force lows that occur, all the gale warnings that occur. And on average each season, counting up all the warnings that are issued by the Ocean Prediction Center, we get on the order of 5 figures in terms of the number of warnings. So it's very active in both basins. Why also do we do what we do? Well, Chris and I both subscribe to alerts from the National Geospatial Intelligence Agency. And a lot of these alerts that come in are for things like cable laying, space debris, sometimes derelict vessels. And on occasion, unfortunately, we see some of this piracy activities, particularly around the coast of Africa. But we also get several, it seems like all the time, reports of things like unreported vessels, or people overboard, or vessels requesting assistance, or distress signals. And what I have here on this, just as an example on this slide, is over a 5-day period back in March of 2019. And I could pick probably any 5-day period and get something similar. 18 known events of things like people overboard, or vessels requesting assistance, or vessels in distress. And while not all of these probably were directly due to weather, I venture to guess that some of these were at least indirectly as a result of weather. And the vulnerable population of the vessels out on the open ocean really requires our vigilance. The strength of the storms really requires our service. And it's our mission, of course, again, for the for the safety of life at sea to make sure that vessels are avoiding things where they can. Here's another example of why we do what we do. And this is an example of a early season hurricane force wind event that impacted the Gulf of Alaska back in late September. The chart on the right shows the hurricane force low moving gradually up the Gulf of Alaska with seas that was analyzed by OPC forecasters of near 24 feet along the coast and 40 feet not too far to the south of the coast. And this was a good case, actually. Many ships, as Chris kind of showed earlier, examples of avoidance, did avoid this, but there were a couple of vessels that didn't. And it's certainly our hope by doing presentations like these that more vessels will try to stay farther out of harm's way, try to avoid the real bad stuff, the hurricane force winds and the high seas when they're forecast to occur. And so at the Ocean Prediction Center, this is just a snapshot of some of the products from the Atlantic webpage, surface analyses that we do, wind and wave analyses for regional snapshot not too far off the coast, as well as a sea state analysis for the entire ocean done once a day. We do surface forecasts through radio fax going out 24, 48, 72, and 96 hours, wind wave forecast for the same stretch of time, as well as wave period and direction forecasts. In an automated sense, we do 500 millibar forecasts over those same time periods, and the same suite of offshore forecasts, high seas forecasts, high frequency HF broadcasts, NAVTEX forecasts that Chris described earlier. At the Ocean Prediction Center, we do over 150 products each day, and these can be found on our website, real easy to remember, ocean.weather.gov. We also do similar products in the high latitudes off the coast of Alaska and parts of the Arctic. And just recently, the NOAA component of the National Ice Center joined the Ocean Prediction Center, is now known as the OPC's Ice Services branch. And it's our really hope that this will really fit in well with the OPC mission, where we can, through providing forecasts, and particularly as we can provide more decision support services, as some of the shipping lanes over the higher latitudes are more available longer, open up more during the year, that we can combine the traditional OPC forecasts of winds and waves with the Ice Center's forecasts of ice to provide a really holistic view of what the weather and the ocean surface conditions are like for mariners who are going to be traveling in those higher latitudes. Chris mentioned the National Digital Forecast Database, and this is just an example of a suite of the NDFD on the right side off the coast of the US. This is back in December 1st of 2020, right around 00 UTC. Top image on the right showing the wind forecast, and the image on the bottom right showing the wave forecast. And in each of those forecasts, you can see really specific detail into what and where the conditions are going to be. Right now at the Ocean Prediction Center, as you can see in the map in the upper left, we provide those gridded forecasts off to about, again, through the EEZ or thereabouts, about 250 miles or so offshore. It is our really strong goal to get those forecasts farther off into the Atlantic Ocean and in the Pacific to match some of the other offices that are already doing that service. And it's just a matter of trying to kind of balance the extreme busy workflow that we have with and maintain the legacy products, with then trying to reach out to more future capabilities across those areas. So we're really looking forward to doing that as soon as we can. So how do we do it? First of all, when a forecaster sits down at a desk, kind of what Chris described, you kind of look at current conditions. And the first thing we look at is satellite imagery. On the left is a visible satellite image over the Pacific back on January 24th of 2020, where you can see very prominently in the middle of the screen the comma head indicator of a strong low pressure system. And then to the southeast of that, following my cursor, frontal boundary, and then a cold front, a very lengthy cold front going to the southwest across much of the central Pacific, northwest of Hawaii, and back into the western Pacific. Other low pressure systems over the western Aleutians, a couple over the Gulf of Alaska, another one close to the US, and so on. So when we look at these satellite images to try to see where the salient features are, and then we also use satellite imagery to help us with wave heights. So here's a swath from altimeter pass from a polar orbiter, giving us an indicator, in this case, around a very strong low pressure system of 59-foot seas. The higher the seas and the hotter the colors. And in this case, there was an indication of 59-foot seas from what the satellite was able to detect near the surface of the ocean. Scatterometer data, the satellite imagery is able to look at wind speed and direction. And in this image, the hotter the colors, the stronger the wind. And in this case, off the Atlantic coast back on January 4th of 2018, there is a very wide swath off the Carolina coast and well off the Virginia Capes of hurricane force winds around a low that was likely located somewhere off the southern mid-Atlantic right about that time. Very broad scale of gale force winds associated with that system, along within the brown several areas of storm force conditions. We also assess observations from ships and some buoys, and I'll talk about that in a minute a little bit more. But once we have all of the kind of like the present view of what's going on in the atmosphere, we turn our attention then to model forecasts. And numerical weather prediction is a big component of how we do our forecasts today. And we can look at a variety of model guidance. And in this image, I just pick out a couple from the Global Forecast System, or the GFS, in yellow, and the European Center for Medium Range Weather Forecasts model in orange. And looking at observations, if we get a sense of maybe which model is handling a situation a little bit better than another, we may tend to lean toward that one as we look toward our 7-day forecast. Also, forecasters, through their experience and rules of thumb that they've gathered over many years of forecasting, they'll also tend to look at the situation and follow the model that they think is going to, produce the best conditions in the forecast to customers. In this case here, the model guidance is pretty good, but you can see differences in low pressure centers. There's another difference in low pressure center here off the coast of the United States. Sometimes the forecaster may try to take a blend of positions and look at conditions, maybe take an average of the two. But again, it all starts with observations. That's the foundation of the forecast. What model is doing the best? What models had the best track record over the last several days, months, or maybe a little longer than that, and create a forecast of wind and conditions, based on that assessment. Same thing is true with the waves. Here in this image, Wave Watch is in the green. That's a model guidance. Things derived from the GFS. You have the European Center's wave forecast in the blue. And while there's, again, a lot of similarity, and this might be difficult to see for those in the webinar, but you can see some big differences with what the Wave Watch showing much higher waves in this part of the North Atlantic, while the European Center's WAM guides is showing higher waves over here and a little bit more to the south. And again, it will be dependent on what guidance we use to establish our winds. We'll tend to follow that same guidance for the waves to create a forecast. Now I'm coming to observations, and this is an image kind of showing the really importance of observations. Over the next couple of slides, I'm going to talk about that. If there's ever an opportunity for people on your vessel to provide observations, know that they're used. They're very important. They're a critical part of our forecast operations. And while you might not get very much feedback from the forecasters that use these day to day, just know that every observation that's sent is extraordinarily valuable to forecasters and is critical input into models to help make them more accurate for the forecaster than to be able to use. And here's an example of why observations are so important. So in this satellite image, you see the comma-shaped cloud feature here over part of the North Atlantic. This is Nova Scotia on the upper left. And this is kind of a cloud feature here with a frontal zone there, cold front there, and the low should be there with the L. The yellow arrow points to an observation that we got from a ship that showed a wind from the northwest at 65 knots, hurricane force conditions. At this time, I think we had storm force conditions in the forecast. We did not have hurricane force conditions. Based on this observation, we were able to update our forecast to make it better for other vessels, hopefully to steer clear, maybe a little bit more than they otherwise would. So this is what real life was showing on the satellite image, but models were indicating something a little bit different. And yellow arrow pointing toward that same observation with the low from the model more to the southwest of the situation. So you can see here in real life, low to the east northeast, model indicator was low to the south. And in that case, the winds from the model were showing something way completely different here, southeast winds, whereas the observation was showing at that time in real time a northwest wind. So just note again the importance of observations. And even though when you look at the whole ocean, the difference in the location of the low is probably what, a degree, maybe a degree and a half in latitude. You're not really very much distance-wise, but how much of a difference that makes to what a vessel is going to show, how much a difference that can make to the accuracy in our forecasts, and again, is an input to guidance, how much a difference that can make positively to how models can perform going out in time. Over the entire globe, and I happen to be the chair of the World Meteorological Organization Ship Observations Team, and this is a map of voluntary observing ship data coverage over the globe. This is back in October 2020. But if you take a snapshot of any month, it's probably going to be about the same. Red is really bad. Pinks and oranges are still kind of bad, pretty bad. Yellow is not quite so bad. Blue's getting better, and green is actually pretty good. You can see across the globe, the amount of coverage, certainly of green, is hardly any. Blue isn't really that much. The majority of the globe certainly is in the hotter colors. And so any observation that we can get, no matter what, is again so important. Here's an example of a scatterometer composite image taken across the Pacific. This is back in March of 2019. And while we do have pretty decent satellite coverage, there's still a lot of gaps. You can see swaths where the polar orbiters are starting to be able to catch what's going on at that particular time. So helping not only to fill in those gaps, but also to validate what we're seeing from satellite, again, or other critical functions that observations can provide for us. One of the last things I'll mention, I highlight maybe the important parameters here. When it comes to just air pressure measurements for global numerical weather prediction, it's a basic goal where if we can get an observation every 15 kilometers taken every 60 minutes, that would be great. If we could get observations, though, even just 100 kilometers taken every 6 hours, that would be for a significant improvement for pressure to be like considered optimum when you're planning and designing observing systems. And envision if over the land, we only had an observation every 100 kilometers taken every 6 hours. Oh my goodness sakes, there would be a lot of gaps in our ability to be able to cover the weather for people in the continental United States. So just one thing to note, for high resolution numerical weather prediction, it'd be great to have observations every 10 kilometers taken every 60 minutes, which is something that we really aspire to and hope to get over time if we can. So in this case here, I wanted to show, this is an example of the low pressure system going off the coast of the United States. This is just back a few days ago. This is on the 28th of January, late in the afternoon. I think it's 21:31, that'd be 4:31 Eastern time. The L is where the location of the low was at the time. At the X was actually a place where we got a ship observation, 70 knots at the time of the observation. The red is an approximation of the ship track. And so, as I talked about before, why it's so important that we do what we do, while it's great to have the observation in this case, the problem is we kind of got the observation in that place because the ship went along the track that kind of went right through the low. And so it's our fervent hope that those out there can practice avoidance as much as they can, keep their vessels, crews, their cargo safe. Again, we were grateful for the observation, but it was in a pretty bad place, probably tracked again, the low went right over their head. Decision support services, Chris talked a little bit about that. We work pretty closely with the Coast Guard District 5 to provide decision support services. We do a briefing every Wednesday, updated, as conditions warrant. In between those times, focusing on the hazards over the next 7 days. And in addition to that, we also have been coordinating more frequently with the Coast Guard to provide products and services for search, rescue missions, sometimes unfortunately recovery missions, so that not only can they maybe help ships in distress, but if they have to go out and take care of things from a rescue or unfortunately from a recovery standpoint, the Coast Guard then can try to keep their crews, their aviators as safe as possible. Just recently, there was an event of a fishing vessel northeast of Hawaii, just in our area, where unfortunately the 10 crew members, I think, abandoned their ship in near hurricane force conditions. And unfortunately, those souls were lost. But we spent several days providing decision support services to the Coast Guard District 17 as they liaised with the coordination center in Taipei to try to get the vessel under tow and take that vessel back to Taiwan. Some possibilities of things we might be able to do in the future using the gridded forecast database. Chris had showed some of those with higher level wind forecasts. I show some wind forecast images on the left. On the right, we may be able to provide hazard end times, something like what Brad and Andy described early on in their presentations with tropical systems. All of these things, I think, from the gridded database can be placed into the ECDIS, electronic chart and information display system, or display information system, and the outputs from that, I think, can be incorporated in there for better overall decision making, bridge management, and so on a vessel. I want to talk briefly about the future of high seas forecasts, and right now our high seas forecasts are, of course, all alphanumeric, and they've been a legacy product that's been around for quite some time. We think that there are probably ways, maybe utilizing the format of the alerts from the National Geospatial Intelligence Agency, to maybe provide more of a polygon look to where the hazards might be for more easier understanding by a vessel operator. And maybe then those polygons can be translated to something like what's on the lower left out of our digital forecast database, where we can better describe in a graphical sense the gales, the storm force conditions, the hurricane force conditions that one may encounter over, say, the next 24 hours or so. I think we need to really improve upon what we're doing high seas forecast wise. We'll still be able to do this legacy product for a long time, but right now when conditions are their worst, they can be upwards of 15,000 characters or more. And it takes a lot to really decipher all of the information from the vast amounts of letters and numbers that we send out each time we do a forecast 4 times a day. So maybe through the future things that we're working on right now in more of a polygon sense, we can provide better information. And here's why it's so important to serve mariners, I think, with 21st century information. This is a graphic of the GFS. It's a 52-hour forecast valid back in December. And right now in our high seas forecasts, we write everything typically with regard to where a low is, and then the winds kind of extending from that low. And the red arrows on the left, this is over the Western Pacific, show all of the low pressure centers that the model has indicated at this time. And you can see on the left, there are at least 6 arrows. Many of these today we can see on satellite. And so if we tried to describe every low and the winds associated with that low, we would never meet deadline. And the forecast in and of itself is already busy with enough lows, but it gets so busy that we really couldn't describe. It'd be just too hard to even try to interpret what the conditions are as you try to make a critical decision. Note that in this case, the stronger winds are in the hotter colors, the gales are in the yellows, the browns indicate the storm force conditions. I don't see hurricane force on here. And so even underneath each low, and Brad pointed this out earlier on, low pressure centers can have many areas where there are lighter winds, even close to the low here in the northeast quadrant of the low, probably going out 120 to 180 nautical miles. Winds are actually not too bad, probably relative to other areas. Doesn't mean the waves aren't kicking up from earlier swell or whatever, but the winds aren't too bad probably in their case. Going over farther to the right, a yellow arrow represents another weaker low. Winds associated with that are probably in the 20 to 30 knot range, mainly in the southern semicircle, but gale force winds, if there are a few spots of yellow over here, in between the high and the low. So these winds are actually associated more maybe with the frontal boundary, not really associated with the low itself or with the high. They're kind of all by themselves. And this would be right for where a polygon could help determine better, I think, in a visual sense, where conditions could be a problem. I wanted to show this image because this year in the Pacific, with all of the hurricane force winds that we've had, there have been a series of container losses, some really significant container losses, some maybe just 50 or 70, and I say just 50 or 70, that's still a lot, but upwards of over 1,000 in a really extreme case. And if you do a search online, you do search online container losses Pacific, you'll find stories of at least a couple of vessels who've lost containers. And one may think that, you know, all these container losses are happening in hurricane force conditions. And this year, the winds in the majority of the cases have been gale force or less. And this is an example of something that happened really not too long ago, back on January 16th, where there's a frontal boundary extending from a big low near the Aleutians. But in this little red circle here, northeast of Hawaii, which is right there, there was a ship that lost many containers. And so it's really under high pressure, just behind a surface trough, where on the right side with the circle, the waves, or the winds rather, were on the order of 15 knots. Now there was that frontal boundary in the area with a change in wind from maybe south to southwest at 15 to northeast about 15. But notice in this wind image, the wave image here rather, they're kind of in a swell gradient. You know, the waves themselves from a system aren't that big, but because of the breadth of the system that's up to the north, the swell train really started to increase with the gradient right near that vessel. And so the one challenge that we face is how to be able to provide more guidance about things like dangerous seas that can have a really big impact on the mariner and critical decision making. That's something I think that we're looking at right now, especially with a team that I'm on in conjunction with Environment and Climate Change Canada, just to see about, you know, things that we can do to better share the potential for dangerous seas with forecasters, and in time maybe provide better information to the mariner. Last thing I'll mention is the decision support at high latitudes, and that's going to be something that's going to be, you know, more important to the Ocean Prediction Center mission over time, as I've already described with our incorporation of the NOAA component of the U.S. Ice Center into the Ocean Prediction Center. Shipping routes are open longer. Ice, where it does form in many cases, is thinner, so it comes in comes in later, gets out earlier, and our decision support services at high latitudes is going to become, I think, an even greater component of our forecast responsibilities over time. Social media, you can see our Twitter handle is there at NWSOPC. Facebook address is there just above that. And if you're interested in a couple of storyboards about hurricane force wind events in the North Atlantic as well as in the Pacific, the web links rather are there for you. And if you aren't able to capture those, just reach out to me and I can get you those web links. You can take a look at that. Really neat, just a perspective of the hurricane force seasons back in 2019, 2020. And so with that, I just want to say thank you very much for your time and attention. Appreciate being here today to provide a little bit about the Ocean Prediction Center to all of you. Lexee, back to you.
Great, Darin. Thank you so much for that amazing presentation. Just looking through the questions here, it doesn't seem as though we don't have any questions for anything today, it looks like so far. But we can hang out for a second just to see if anybody's typing something in that box right now. Stay tuned. Or if there's anything in the chat box, which it doesn't seem as though we have much of anything. And it also seems that we have a lot of leftover time. So I just want to say thank you to all the presenters. You guys were really efficient with your time, and I didn't have to bother anyone to like move their presentation any faster. But it seems as though we don't have any questions, unfortunately. Actually, we do have one from Brianna Hillstrom. We can email questions later to Darin. Darin, I'm guessing this is for you, and she was asking if you can email you later. I believe you got your email put up on this last slide, correct?
Right. So if there are any questions for myself or for any of us that presented here during the day, feel free to send an email. If you have them directly to me, you can send it to me. If you forgot email addresses and you have something for somebody else and you see my email up there, send it to me and I'll get it to them. However it works, we'll make sure we get the question answered if we can answer it to the right person. So that'd be fine.
Great. It looks like we've answered Brianna's question. Thank you for the question. And as we wrap things up, I just want to say thank you again, Darin. That was a great presentation. And to everyone who is joined today, I really appreciate your time. So if we don't have any more questions, once again, we've recorded the workshop and we'll be posting it to the National Hurricane Center's YouTube page. I've put that on the chat box for you to copy and paste that link if you would like. And Chris, I know we have a little bit more time. Is there anything else you would like to mention?
I just wanted to say thanks for participants. Hopefully this was helpful. Perhaps we could, if there's interest in doing this again next year, we could make it a bit more interactive. This is something that we're hopeful that can be helpful going forward. You all have to make life-threatening decisions or life-saving decisions out over the open ocean. So whatever we can do as forecasters to assist, please let us know.
Great, thank you, Chris. Well, I will leave the GoToMeeting open for the next few minutes. If anybody has any other questions they would like to throw into the question box, and I will shortly close everything out. Thank you again so much for joining us today. It was a great workshop. I really appreciate everybody's presentations and attendance. So thanks again.
Thank you.